Suppose we have a given problem which is 20x squared plus 20y squared is equal to 900. And our goal is to find y second prime. What I mean by y second prime, it actually means finding this one. All right, we're going to find this one. Or, in other words, we're going to find the second derivative. All right? So in this equation, we're going to find the second derivative with respect to x. Now, the question is, how are we going to do that? So we're going to apply implicit differentiation. How do we apply implicit differentiation? Well, it's just like you are differentiating a function or a given expression, but the thing is we have two variables given. One is we have an x variable and the other is a y variable. So if you're going to differentiate a term that has a y variable, what you're going to do is you're going to include y prime. All right? So again, if you're going to differentiate a term that has a y variable, you're going to put what? Y prime after you differentiate it. So for example, we have x is equal to 2y squared. And I want you to get the first derivative of this equation. So if I'm going to get the derivative of x, the answer here would be 1. This is according to power rule of differentiation, or let me just make a rule here where the term and has a uh, has a variable of x where each exponent is equal to 1. So the derivative of any term that looks like this is the coefficient itself. So the derivative of x is just simply its coefficient 1. So here, let's differentiate the 2y squared. Here we're going to apply power rule of differentiation. All right? First, we have a constant here of 2, so we're just going to leave it be. That's according to the constant multiple rule of differentiation. And here we're going to apply power rule of differentiation. So all we need to do is just bring down the exponent, copy the given, which is y squared, then subtract the given exponent by 1. And that is how you apply power rule of differentiation. And the thing is, okay, it's already differentiated, but then it has a variable of y, right? So do not forget to include y prime, right? Do not forget to include y prime. Or you can just use a notation dy all over dx. All right? So for me, I would rather use y prime for more convenient way to solve it. Okay? So to simplify further, we will have 1 is equal to 4y prime. That's how you apply implicit differentiation. So what we just did here, we're going to apply that to the problem for today. All right? So we're going to find the y second prime or the second derivative. Okay? So let's start. Let me just erase this one. Before I begin differentiating, I think I can simplify this problem. This 20x squared plus 20y squared is equal to 900. I can simplify this one. So the thing is, I think all of them, all the terms from left to right, they're all divisible by 20. So I can just simply divide both sides by 20. So what happens is that if we divide both sides by 20, on the left side, we will have x squared plus y squared. And on the right side, 900 divided by 20 will give you 45. Am I right? I'm just making sure. I'm going to use my calculator. I have to make sure. Yes, it's exactly 45. Now that you simplified the given equation, that's much easier for you to differentiate. So, speaking of differentiation, let's find the first derivative because before you find the second derivative, you must first find the first derivative of this equation. Okay? So here, the first derivative of equation, we have x squared. So apply power rule of differentiation. Oh wait, sorry, my mouse. So yeah, again, apply power rule of differentiation. So bring down the exponent, which is 2. Copy the given x squared. Then the given exponent will be subtracted by 1. So we will have 2 minus 1. Plus, we will differentiate y squared. So we will apply power rule, the same thing. So this would become 2y raised to 2 minus 1. But again, after you differentiate a term that has a variable of y, do not forget to put y prime. All right? Is equal to the derivative of 45, which is a constant term. Remember that if you're going to differentiate a constant term, whether if it's rational or irrational, the answer is 0. So hence we have 0 as the answer. So let's simplify our, wait, I'm having a hard time here, right? So let's simplify our solution. This would be 2x raised to 1, or 2x plus 2y prime is equal to 0. Now, let's simplify, because you see, this expression on the left side, they have 2 on both terms, 2x and 2y prime. So we can remove the 2's by dividing both sides by 2. So this would become x plus y prime is equal to 0, right? So it seems like we already, uh, not only that we get the simplified answer, but we already get the first derivative of this equation. So here, it's up to you if you can proceed to differentiate it again. Like, since we already get the first derivative, so we can now differentiate it one more time for us to find the y second prime. Or let's find first y prime before we differentiate again. So for me, if I'm going to solve this problem, I'm going to find y prime in this equation before I will find the second derivative. All right. So I'm going to do that here in the solution. So let me just erase the writing here. All right. Let me just bring this up. Okay. So I will find y prime. So I'll just put x to the right. So I will be having y prime is equal to negative x. And divide both sides by y, I'll be having y prime is equal to negative x all over y. Or we can just simply bring this negative sign beside the fraction, so we will have y prime is equal to negative x all over y. And I already found my y prime. Here I can find the second derivative. So if you're asking me why did I find y prime instead of just differentiate it thoroughly? It's simple. Because after I find my y prime here, be I wouldn't be having a hard time to find my y second prime. So speaking of y second prime, we will get the second derivative by differentiating this equation. So let's differentiate it. What's the derivative of y prime? So here, since this is in the first derivative, differentiate it one more time will become y second prime. So it's like this, like you have y, right? The derivative of y is y prime. If you're going to differentiate y prime, this would become y second prime. If you're going to differentiate y second prime, this would become y third prime, and so on and so forth. So hence, differentiate y prime will result to having y second prime, right? Now, on the right side, here we can apply quotient rule of differentiation, all right? So first and foremost, constant, we have a negative sign here. So we can just leave it be, don't touch it. That is according to the constant multiple rule of differentiation, where if there is a constant, rather like a coefficient to the function, you can just leave it be, don't touch it. You do not need to differentiate it. All you need to differentiate is the one that's beside the coefficient, which is the function. So we're just going to differentiate x all over y. So here, if you're going to differentiate x all over y, we're going to apply quotient rule of differentiation. So basically, the formula of the quotient rule of differentiation, thanks uh, to my discussion, or rather my class in calculus, the formula for simplicity's sake is low d high minus high. Oh, hold on. Wait. High times d low all over low squared, right? Wait, let me just bring down the solution here. All right, let me just bring down because my camera might block it. So yeah, going back, so this is the formula. Low D high, high D low, all over low squared. So low, basically, it's the denominator. D high, when you see D high, means the derivative of the numerator. What is above it, you're going to differentiate it. And similarly, if you hear D low, that means you're going to differentiate the denominator, or the one that is at the bottom. Okay? So let me just erase this one, and we're going to go back here. All right? So this would become y second prime is equal to negative, then times, okay, let's differentiate this. So we have low, which is y, times d high, the derivative of x. So this would be 1, minus high, which is x, times the derivative of low, that would be 1, right? But again, if you're going to differentiate a y term or y variable, don't forget to put y prime. So 1 times y prime is just y prime, right? All over the square of the low, or the square of your denominator. So as a result, you will have y second prime is equal to negative y minus x y prime all over y squared. All right? So you may be thinking, maybe that's the answer, because overall we found our y second prime, right? But we can simplify this problem even more. We can simplify it. Let me just erase the formula here, right? You can just pass backward if you want to remember it. Now, y prime, right? We can actually substitute y prime as negative x all over y, right? We can do that actually, right? We found our y prime as negative x all over y. We can substitute it here. And if you're asking me, why is it possible, or rather, why is it valid for me to substitute y prime as negative x all over y? Because once you differentiate the equation at least once, you'll be forming a different equation, right? Like for example, I have the slope-intercept of slope-intercept formula, which is y is equal to mx plus b. And let's just say you get the, oh wait, no. There you go, this one. Let's just say you have this one, the slope-intercept formula, and you want to find the first derivative of this one. So you will have y prime is equal to m, right? By the way, m and b here are constants, all right? So we assume that they're constant, so this would be the result after we get the first derivative of the equation. Now, as you can see, from the original equation to the first derivative of the equation, you see they're both different, right? So here we can apply system of equations. We can substitute. So, right, we have y prime is equal to m. So that means we can substitute m as our y prime. So we have y is equal to y prime times x plus b. All right. I hope you get the idea here, because that's what we're going to do in this case. All right. So since y prime is equal to negative x all over y, therefore we can simply rewrite this as negative y minus x times your y prime negative x all over y all over y squared. Let me take a look if it's visible. Oh, it is in fact visible. Okay. Now let me just shrink this thing small. Let me just shrink this one so that I can write even more. So let's write our solution here. Okay, so let's simplify. So we have y second prime is equal to negative y plus x squared all over y squared. Here, you can leave your answer. You can leave this as your final answer, but it's much better if you're going to simplify it further. All right. The more simplified your answer is, the better. Okay. So you see, we have a whole term and a fraction term, or basically a term that is in fraction. So we can just combine them into whole. So I'm just gonna go direct to the point. This would become y squared. Wait, hold on. Wait. Let me just erase. So this would become y squared plus x squared all over all over y squared. And the thing is, we have a complicated fraction because on the numerator it is a fraction, while on the denominator it isn't a fraction. So we have to simplify this one. So to go to the point, we will have negative. Wait, hold on. So we will have negative y squared plus x squared all over y times 1 all over y squared. So the answer here would be negative y squared plus x squared all over y cubed. Okay? So you might be thinking, I think this is the simplified answer, right? You might be thinking. So yes, you can leave that as your answer, but we can actually simplify it one more time, right? So what is the simplified of this, or the most simplified of this answer? Let's go back in our previous solution. In our previous solution, right, remember this one, 20x squared plus 20y squared is equal to 900. Before we differentiate, right, we simplify it. And the simplified form of this given equation is what? Is x squared plus y squared is equal to 45. Now, if you're going to apply it here, let me just cut this one. Oh, wait. Is it visible though? Wait. Okay. So yeah, going back, if you're going to relate, rather not apply, relate it here in this final answer, we notice that we have y squared plus x squared. And the thing is, x squared plus y squared is equal to 45. Even if you would interchange the terms here, okay, like instead of having x squared as the first term, instead we have y squared plus x squared. Here, still it's equal to 45. All right. So point being, we can just simply substitute x squared plus y squared as 45. So this would become y second prime is equal to 45 all over y cubed. And that is your final simplified answer. This is your y second prime, or the second derivative of this given equation.